Hi everyone, this is Elena Lubimtseva in Environmental Studies and Geography for 12, Global Climate and Environmental Change. Unit 3, Impacts of Climate Change, Vulnerabilities and Adaptation, would cover climate change impacts on water cycle, ecosystem, human health and land use, as well as concepts of vulnerability and resiliency and climate change mitigation and adaptation strategies. In this unit, we would examine some examples of impacts of climate change. We will talk about vulnerability and the flip side of vulnerability, which is resiliency. I will specifically address different dimensions of vulnerability, such as exposure, sensitivity, and adaptive capacity. And then we would also talk about what we can do in order to control climate change, both in terms of mitigation strategies and adaptation strategies. And both mitigation and adaptation are two important components of climate action planning. So as you all already understand very well and know from our readings that climate change is much more than just global warming, it's much more than just a temperature increase. And it does lead to very different changes in different parts of the world. It means very extreme weather. It means significantly more precipitation in some places, fallen just within one day, and it can also lead to much less precipitation in other places. It leads to very volatile climate with significantly more intense hurricanes and tornadoes in the atmosphere. It also means melting glaciers in many parts of the world. It also means declining ice mass in both our polar ice caps and in the mountain glaciers. It also means the disappearance of huge amount of ice in Arctica and in the Antarctica, and huge icebergs floating away from the coast, like this iceberg B49 carved from the Antarctic glacier this year, which is the size larger than Texas or larger than France. It also means that, of course, we see very different patterns of temperature changes, precipitation changes, pressure changes all over the world. In the lab 2, you were able to explore, and actually in the lab 1 as well, you have explored changes in the temperature under different climate change scenarios in different parts of the world. So here you can clearly see that overall, we see both from the historical meteorological data and from the model predictions that temperature increase is significantly more intense in the Arctic compared to the tropical areas. And also the northern hemisphere is warming up much faster than the southern hemisphere because it has significantly more land. So in some places of the world, we see unprecedented floods, and we are experiencing lots of flooding here in the United States, in the South, in Midwest, in the Southeast this year, and pretty much every year in the past decade, and every year these events are becoming more increased. Many parts of the world are experiencing very significant, unprecedented flooding. Like this is an example of Tamil Nadu in India with unprecedented amount of precipitation. As you can see, essentially the entire area is complete. We experienced very significant flood here in Grand Rapids in 2013, and we had another flood just a year ago, but it was much better managed, and so we will talk about adaptation strategies as well. On the flip side, as we see catastrophic flooding in some parts of the world, we also see increase of very intense droughts, and this is leading to decline on food security and desertification, degradation of many areas that used to be suitable for agriculture and now they're becoming wastelands. We also see, especially this year, like I think forest fires are really on everybody's mind with what is happening right now in California and in Washington and in Oregon, what is happening in Colorado is devastating. And there is a very strong evidence that increase in frequency and intensity of forest fires is directly related to climate change. We cannot address the problem of forest fires just by better forest management. It's unrealistic, because forest fires are the results of much drier and warmer conditions. We have more and more prolonged droughts in those areas. And so obviously this is not something that can be solved just at the local level. We do need to deal with climate change in order to deal with its impacts. So it is a fairly old slide from forest fires in Alberta in Canada 4 years ago, but again this year and as well as during the past few years, they all have been the warmest year on the record, and we are dealing with unprecedented forest fires in the United States, in Southern Europe, in Siberia. These places are literally on fire. I also want to point out that ecosystems itself, and so this would also lead us to the conversation about forest fires, but many other changes in the ecosystems. Ecosystems are very sensitive to climate change. And so our vegetation cover all over the world is literally changing as a result of climate change. And climate change is, again, it's much more than just temperature increase, because vegetation is sensitive to the surface temperature changes. It's also sensitive to changing patterns of precipitation. So it might be dry in some places, wetter in others. The seasons, the pattern of seasons is changing. And vegetation is also responding to higher concentrations of carbon dioxide. And there are different plants. Some of these plants, the majority of plants that we have used to see around them, are so-called C3 plants. These plants have evolved under lower temperatures and under lower concentrations of CO2 than what we have today. And so they have some difficulties to adapt. C4 plants, on the other hand, are tropical plants. The majority of them are tropical plants. And so in some parts of the world, we actually see that C3 plants are kind of yielding to the C4 plants. And then CAM pathway or CAM pathway, those are your succulents, cacti, for example. And those plants are adapted to storing water and then photosynthesizing during the nighttime because it's too hot during the daytime. So those are desert xerophytic plants, succulent plants that store lots of water. So as we are experiencing climate change all over the world, and we are experiencing higher temperatures, changes in the precipitations and higher concentrations of carbon dioxide in the atmosphere, different plants, depending on their photosynthetic pathways, have different capability to adapt, and some of them might be actually thriving under these new conditions while others disappearing. And so I'm sure you all have heard before about the invasives, and of course invasives are the result of other processes, right? For example, we might be using invasive plants for our landscaping purposes, and plants are traveling the world today as humans are traveling the world. But the problem is that some of those invasive species that are coming from very different climatic conditions are actually thriving in those new areas where they didn't exist before. And as a result, native vegetation cannot compete anymore. So the entire ecosystems are changing as a result of climate change. Climate change impacts the geographic distribution of our plant species. So as climate is moving, plants are moving following those climatic conditions as well. And so we spoke before about climate models, but there are also biogeography models that can take information from climate models and show us how vegetation is going to look geographically in the future and how ecosystems are going to change as a result of this response of vegetation to climate change. So geographic patterns of our ecosystems are changing as our plants are moving north. For example, you probably all know what is the state plant, what is the state tree of the state of Michigan. It's white pine, right? Well, white pine is about to immigrate to Canada because conditions in Michigan are not anymore suitable for its ecology. It's becoming too warm. And it's also, the pattern of our precipitation is now different. We have significantly more rain and we have much less snow. We have almost no snow in winter. And so we are projected to lose our state tree probably by the middle of the century, within the next 30 years. Another thing that is happening as a result of climate change is the change in the plant productivity. So as I mentioned before, there are plants with different photosynthetic pathways. They metabolize carbon from the air differently through the process of photosynthesis. And so some of these plants can actually adapt better to climate changes, but also higher concentrations of CO2. For some of them, it's impossible or it's significantly more difficult, and it leads to very big changes in productivity of plants. So some ecosystems are actually gaining biomass, and other ecosystems are losing their biomass or entirely disappearing. Another thing that is also changing very rapidly as a result of climate change that I mentioned already are the changes in the biodiversity, and overall we are losing biodiversity. Climate change, along with many other factors such as landscape fragmentation, is the major factor that causes loss and disappearance of many species. Many species are already endangered and they are projected to disappear entirely. So this overall leads to decline of biodiversity and disappearance of species that otherwise could be, maybe we are losing cure for different diseases. We are losing plants that have been supporting us in the process of evolution for thousands of hundreds of thousands of years. And so we are losing our resources before we are even realizing this. Climate change is also impacting basic ecological processes. In every ecosystem, everything is related. There are food webs. Some animals are dependent on other animals, or they're dependent on plants, and these plants are dependent on pollinators, and the pollinators are dependent on those plants. Birds are dependent on insects, and so on and so forth. So in ecosystem, everything is interrelated. Fungi, animals, soils, everything is connected. And so as we are losing some of those species as a result of climate change, all these ecological processes are becoming disrupted and the entire ecosystem is at very high risk of collapse. And we spoke before about positive and negative feedbacks that are so important in climate system. And there is a number of positive feedbacks between climatic system and ecosystems. Ecosystems are a part of climate system, and so those feedbacks are becoming disrupted as well. We spoke in Unit 1 about kind of this classical example of positive feedback when vegetation degradation is causing decline in precipitation, and decline of precipitation is in turn causing the decline of vegetation till the area becomes complete desert and there is no more moisture available for formation of cloud. So there are many other of those feedbacks that connect our climate in different parts of the world to health of ecosystems that are thriving under those climatic conditions. And so as we are thinking about climate change, remember that it's not only climate that is changing, the entire Earth, the entire life on Earth is changing as a result of our impact on climate and anthropogenic climate change. We now risk losing up to 50% of all land species in this century, and climate change is the #1 reason of species and the loss of biodiversity. This involves not only wildlife, it also, climate change has unprecedented impact on our agriculture and food security, on agro ecosystems. So this is the citation from David Lobel from Stanford University, who said, I think there has been an under-recognition of just how sensitive crops are to heat and how fast heat exposure is increasing. So we are experiencing, just like as in the natural ecosystems, we see that plants are literally moving as a result of climate change, responding to changes in moisture, changes in the amount of precipitation, changes in the seasonality, and of course, changes in precipitation. The same is happening with many agricultural crops, and this is going to affect dramatically and how we can grow in different parts of the world and what would be conditions of our food security in future, and conditions for our health as well. So what we see on this map are the changes in the patterns of tropical diseases as a result of climate change. Of course, this year we are very much all concerned about global pandemic of COVID-19, but in many ways, what we're experiencing right now is just a little preview of what is going to happen as a result of climate change, unless we mitigate it as quickly as possible and collaboratively all around the world. Many of these infections, probably have been on your mind before, and many of them are much even more dangerous than COVID-19. West Nile virus, Zika virus, dengue fever, Chagas disease, Rift Valley fever, and so on and so forth. So you can clearly see that tropical diseases are on the move, and they're on the move as a result of changing climate conditions. Here in the United States, we are experiencing unprecedented increase of many infections that previously didn't exist in these areas. We have dengue fever now in southern states. We have, Michigan is very vulnerable to West Nile virus. We have growing number of cases of Lyme disease, and this is, again, it's a preview of what is going to happen if we don't take it seriously as soon as possible. Now, climate change and health are related in so many different ways. This is not just about infectious diseases. Climate change is, of course, is a reason why we're experiencing much higher frequency and much higher intensity of extreme weather events. And extreme weather events are one major factor of increase in fatalities. Climate change impacts the quality and the distribution of our water. Climate change has huge impact on mental health. Um, if you are living in the area that is increasingly affected by extreme weather events, it has a significant impact on the number of cases of depression and anxiety. We see increase of allergy all over the country and all over the world as a result of changes in climate. Heat stress is one of the key reasons of growing number of cardiovascular diseases, especially in large cities where the temperatures are much higher. They're even more amplified by the urban heat island effect. Air pollution is on the rise, and of course, CO2 is one of the causes of air pollution. So we need to think of global warming as one of the major cases of air pollution and treat it as such. And of course, I mentioned already that climate change has profound impact on our food. And of course, all this is interconnected. It's a very complex system. It's a complex web, and we need to deal with it in a systematic way. We need to think, as we think about climate change, we also need to think about how we can improve our healthcare system, how we can provide better mental health care, how we can improve and modify our food systems, how we can be more resilient to extreme weather conditions. So with this, I want to introduce our next concept, and this is the concept of human vulnerability. So, vulnerability is different from impacts of climate change because it's really about how vulnerable is a community or an individual to climate change, the characteristics and circumstances of a community or a system or asset that make it susceptible to the damaging effects of climate change or damaging effects of other hazards. So the IPCC has really shifted from understanding vulnerability to climate change as the degree to which systems are susceptible to and unable to cope to adverse impacts of climate change, to propensity or predisposition to be adversely affected. So if you compare how IPCC was thinking about climate change in 2007 and how is it thinking about it now, the focus is really on how susceptible we are to impacts of climate change. The same impact might have very different consequences for different communities. So there's a significant difference between these definitions because it's not just only about physical events. It's also about social and economic characteristics of our society and our ability to cope and be resilient and adapt. So let's examine this diagram, the scoping diagram of vulnerability. It really helps us to understand these three aspects or three dimensions of human vulnerability to climate change. By the way, this article by Polsky, Neff, and Yarnall is available on the Blackboard. So please take time to read it in order to better understand these three dimensions of vulnerability. The first dimension is exposure. Exposure means essentially where we are, to what extent we are exposed to impacts of climate change. An impact of climate change can be forest fire or drought or flood, and so our exposure would very much depend on physical geography, on where we are, to what extent we are vulnerable being within an area affected by this adversity caused by climate change. So depending on if your house is on top of the mountain or in the flood zone and the floodplain, your exposure to the same flood is of course very different. Or if you are living in the area which is affected by forest fires, your exposure is much higher to the forest fires than someone who lives away from the areas which is affected by forest fires. So this is fairly simple. It's very clear to understand. And for many years, this was the primary focus on understanding vulnerability. Today, we understand that there are two other dimensions that are just as important as exposure, and those are sensitivity and adaptive capacity. Sensitivity essentially means all the characteristics such as technology available for the community, demographic characteristics such as age and gender, income of people who live in the community, um, all the assets, everything that helps them, the quality of the infrastructure to deal with exposure. So we can be all exposed to the same impacts of climate change, let's say flooding, but our sensitivity would be very different depending on what is your well-being, what is your access to healthcare, what is your health, how good is your nutrition, how physically fit you are, what kind of technology you have at your disposal, and so on. So sensitivity very much depends on who you are, and there is a mounting evidence that urban poor or communities of color or other marginalized groups are significantly more vulnerable to many impacts of climate change that communities who have much more assets. In certain situations, women might be much more vulnerable than men. Infants and elderly populations are the most vulnerable people. So in many ways, vulnerable groups who are vulnerable right now to COVID-19, those are the same highly sensitive, highly vulnerable groups to many impacts of climate change. The third area, the third dimension of human vulnerability is human adaptive capacity. Adaptive capacity essentially means what we have as a society or as an individual or as a community or as a country to deal with adversities caused by climate change or any other adversities such as global pandemic, for example. Adaptive capacities can include policies. Do we have a national policy in place in order to help everyone? It can include your educational level. Can you make good decisions for yourself in order to adapt? It can include your preparedness in terms of your willingness to change your behavior. Right now, we're adapting to life with pandemic. In order to adapt, we need to be mindful of each other. We need to wear masks. We need to protect not only ourselves but also others. We need to maintain social distance. So those are kind of adaptive measures. And the adaptive capacity depends on what kind of institutions we have in place. If we have a good institution, if we have good policies, we are likely to do much better job to adapt to whatever negative impact of climate change or any other danger is affecting our society. We see many examples. Again, I want to use this analogy between the way how we adapt this year to the life with pandemic to our adaptations to climate change. We see many successes around the world. New Zealand, for the second time, was able to eliminate COVID-19 entirely because this country had a very good system of policies and institutions in place that kind of encouraged all citizens to work together and coordinate their efforts. When we have chaotic institution or when we don't have very good coordination, adaptive capacity really falls on the shoulders of local governments or citizens themselves. And so you can think about local adaptations that you need to make your own decisions how to protect yourself. So think about it: 3 dimensions: exposure, sensitivity, and adaptive capacity. They all matter in the way how we are experiencing impacts of climate change. So it's important to realize that human vulnerability to climate change has both its biophysical aspects. For example, we can be vulnerable to sea level rise and land losses as a result of this, depending on where we live. Or we can be sensitive or we can be vulnerable to changes in agricultural production, depending on what we eat and, again, where we live, to water resources availability, to direct impacts of climate parameters on vector-borne diseases or waterborne diseases or cardiovascular diseases that are associated with heat waves. So those are kind of problems and aspects of human vulnerability that we can study with the help of AOGCMs, right? The general circulation models that you're already familiar with from Unit 2. And these models help scientists to develop climate change scenarios, and we can predict of what kind of impacts we will experience in different areas. We can predict changes in the agricultural crops, so we can predict in changes in the water resources. We can predict changes in the sea level rise and develop strategies on how to deal with them. And at the same time, there are also human aspects of our vulnerability to climate change. And this is where really social science is important. Human behavior, lifestyle, political system, capacity of our institutions, culture, those are all human aspects, societal aspects that also contribute into the level of our exposure, sensitivity, and adaptive capacity to climate change. And there is a growing body of knowledge showing that cultural, social, economic, and political aspects of human vulnerability are perhaps just as important or maybe even more important than impact of climate change itself. The way how we live through climate change, the way how we deal with climate change as a society has a profound impact on how vulnerable we are, how we are experiencing those impacts. So those characteristics of our society, such as strength of democracy and civil society, the societal view of nature, do we respect our nature? Do we protect nature? Um, what are the measures of regions' economic wealth, equity, welfare of all its citizens? What is the diversity of our natural resources and sources of our income has again profound impact on our vulnerability. Again, there are lots of studies showing that society with diversity of resources and diversity of economic activities, diversity of sources of income are significantly more resilient to climate change versus those societies who kind of count on monoculture. The same is true with what kind of fuel, for example, we're using. Right? If we continue dependence on fossil fuels, not only it increases our emissions and not only it increases climate change, but also it makes us more vulnerable to the consequences of climate change and impacts of climate change because we are relying on like on this very small pool of options. As we diversify our sources of energy, we are also becoming less vulnerable. The same with agricultural products, right? Those countries who rely primarily, whose economies primarily rely on monoculture, on growing, many small tropical countries rely primarily on exports of just several crops such as cocoa, coffee, and so that makes them extremely, extremely vulnerable versus a well-developed, diverse economy with many different options. Political stability also shown being a major factor of resiliency to climate change. Obviously, the more stable we are, the more collaborative we are, the stronger our institutions, the stronger our governments at each level, from local to federal, the better we are equipped with mechanisms to deal with impact of climate change. So institutional development and capability of institutions to cope with environmental stresses or health pandemic stresses as right now and to adapt is crucial for decreasing human vulnerability to climate change or to COVID or to any other future viruses that might come our way in future. And by the way, many experts are telling us today that, like even though, COVID-19 eventually would go away, we are really moving to that future world where new viruses and new threats would be emerging again, again, and again. And so building institutional systems that are capable to cope with those disruptions has never been important as it is now. So human vulnerability to climate change can be defined as vulnerability is a function of three variables. These variables are exposure, sensitivity, and adaptive capacity. And human vulnerability correlates positively with exposure and sensitivity, and it correlates negatively with adaptive capacity. Right? The higher is our adaptive capacity, the more tools we have at our disposal, the stronger are our institutions, better our policies, the lower is our vulnerability to impact of climate change. So think of any example of climate change, think of any example of vulnerability indicator. Let's take a look at our vulnerability to impact of flooding. We all can be exposed to the same flooding, but again, the indicators of exposure could be elevation, slope, type of terrain, soils, distance from the coast, distance from the floodplain, the speed of the wind in the area, and so on. So you can see, depending on all those different characteristics, we can be exposed differently to the same flood. And examples of indicators of sensitivity could be population age, gender, health, wellness, fitness, mobility, your occupation, your lifestyle, and so on. So again, think of it, we can be all exposed within the same degree to the same flood, but depending on those sensitivity characteristics, our chances to survive and thrive and live through this event could be very different. And finally, indicators of adaptive capacity could be our access to information, our access to education, access to evacuation plan, transportation, your insurance, and so on. Again, all those could be questions of life and death, really determining how you would go through the same experience. So the same flood could have very different consequences, let's say for someone who has high income and good insurance versus someone who can become homeless as a result of the same weather event. So it's important to keep this in mind as we are thinking about what can be really done about the consequences of climate change. Now, you all have probably heard the word resilience before, and so in many ways, the resilience is really kind of the opposite side of vulnerability. Both vulnerability and resilience are focusing on many similar issues, and they have exactly the same three dimensions related to exposure, sensitivity, and adaptive capacity. But resilience is really the ability of a system and its components to anticipate, absorb, accommodate, or recover from the effects of a hazardous nature. And so think about it, in terms of bouncing back, right? Like when the system is resilient, or when a person is resilient, or when a country is resilient, it goes back, it bounces back to its homeostasis, to its original state. So this term resilience is coming from ecology, and it describes the ability of any system to go back to its original stable state. So resilience can be slightly differently understood in engineering, in psychology, in disaster management, in socio-ecological systems, scholarly traditions, but it also means, your ability to bounce back. So this is essentially the opposite of vulnerability. And we can think about resiliency very much along the same line as before, right? So we can think about it in terms of our three dimensions, such as exposure, sensitivity, and adaptive capacity. From there, I would like to introduce a few more concepts. What do we do in terms of planning for climate preparedness? And so there are really different ways of looking at planning. We can look at it from the perspective, we can look at climate planning from the perspective of climate mitigation. And climate change mitigation means slowing the rate of global warming by slowing the rate of carbon emissions. We can also think of climate preparedness in terms of climate change adaptation strategies. And climate change adaptation means taking steps to live with some of those effects of climate change, but be more prepared and decrease our vulnerability and increase our resilience in various ways. And finally, planning can mean planning for resiliency, to becoming more prepared to the effects of climate change. So there is some degree of overlap here between climate adaptation planning and climate resilience planning. But climate resilience planning can be even broader, right? It can mean, being more prepared in the sense of, living through this experience and having very strong economy or very strong institutions, so very good welfare system that would support every citizen. It can mean having better healthcare system that would give you more chances to not to die, as a result of some of those effects. It can mean to have more resilient local food system that would provide enough of food to all its citizens. So it really can mean very different things. Going to look a little bit more at some of those mitigation, adaptation, and resilience strategies. So some scholars believe that built-in climate resiliency really means integration between mitigation and climate adaptation strategies. We do need actions that would reduce emissions that cause climate change, and at the same time, we also do need measures and actions to manage the risks of climate change impacts. And when we have both, this is really like sort of the ideal approach when we can work both on the local priorities and global priorities, right? Adaptation is much more local action, original action. Mitigation is about cutting our emissions that have impact at the global scale. And we do need both, and many of those solutions really serve both purposes, such as water conservation or transition to away from fossil fuels to the renewable energy, energy conservation, better education so that all people could understand really what causes climate change and what can be done about it. Good communication, creating sustainable communities, planting urban forests, just improving our quality of life in our cities, supporting local systems. All this makes us more resilient, and it also serves both purposes of climate change adaptation and climate change mitigation. I want again to reiterate the importance of both planning for climate change mitigation and climate change adaptation. Worldwide, there have been considerable progress achieved in the recent years in understanding the steps and recognizing the urgency of and planning for climate change mitigation measures at the international, national, regional, and local scale. I think today everyone would agree that we do need to cut our carbon dioxide emissions as soon as possible to stop climate change. And probably the majority of people would also agree that we know quite well what it takes. We need to wean ourselves from fossil fuels. And of course, also we need to do other things such as conserving energy and planting more trees and being less wasteful and so on. While mitigation planning works to reduce current and future greenhouse gas emissions, climate adaptation strategies really seek to adjust the human environmental systems in response to actual and expected, predicted climate changes. And so in order to minimize this future harm and also exploit the beneficial opportunities of future climate change scenarios, we need to plan for them now, and we need to build those adaptation strategies in our urban planning and land use planning. According to the United Nations Framework Convention on Climate Change, it is estimated that by 2030, we would need investments of order 171 billion US dollars just to meet the global demand for adaptation. And most of these investments are going to happen in developed countries. So we need those adaptations, and we need to start right away before it is too late, because climate change adaptation investments really help us to protect from much more expensive and probably unrepairable damages that would happen as a result of climate change if we don't implement our climate change mitigation policies at the same time. So it's important to clearly understand the difference between climate change mitigation strategies and climate change adaptation strategies. Mitigation is usually defined as the prevention of the effects of climate change through reduction of greenhouse gas emissions to the atmosphere or increasing net terrestrial or ocean sinks. Mitigation is not considered as being synonymous with adaptation or with coping strategy. So mitigation is really what we do either to cut our emissions or to increase carbon sinks. So obviously, supporting renewable energy is one of the ways to mitigate climate change. So if you are familiar with Drawdown, the most comprehensive plan ever proposed to reverse global warming, edited by Paul Hawken, those are some top solutions for climate change mitigation, such as improving our refrigerant management to reduce the HFC's emissions into the atmosphere, implementing wind turbines, especially onshore, reduced food waste, plant-rich diet, tropical forest, family planning, educating women and girls, solar farms, silvopasture, and rooftop solar energy. Those are all 10 top solutions for mitigating climate change. By the way, this is a book that I use as a textbook for GPY 101, Sustainability and Place. So wind energy, one of the top, in fact, this is the second top solution for climate change. Globally, wind could supply worldwide electricity consumption 40 times over. So think about it, 40 times over. With wind turbines, don't need coal, we don't need fracking, we don't need oil. Wind energy is sufficient if we just implement it, if we have good policies in place. There are some really good developments. So if you look at the new electric capacity in the United States in the past few years, actually 62% of all new capacity was coming from solar and wind. And you can see that it's kind of equally distributed between solar and wind. And then, of course, the third one is natural gas. Now, I wanted to say that there is really nothing natural about natural gas. Natural gas is methane. And natural gas is a major source of carbon dioxide. So natural gas is not a solution for climate change, but wind and solar are. Why we are experiencing this quick growth of electric capacity from the renewables, even without very supportive policies right now in this country, simply for the economic reasons. Wind and solar are significantly cheaper. It simply makes sense. So we do need good climate policies in this country, and we do need policies that would support this transition rather than slow it down. We don't need to continue throwing away taxpayers' money on subsidies to fossil fuel energy to subsidize climate change. It makes total economic and environmental sense to start using significantly more wind and solar and have appropriate policies in place. This is the map of cities in the United States that are already committed to going 100% renewable. And this map is actually a few years old. We see more and more cities becoming 100% committed here in Michigan and as well. So Traverse City actually committed to going 100% renewable, and more cities would follow. So this is very assuring, very reassuring, and we see a few cities in the United States who are already there: Aspen, Colorado, Rockport, Missouri, Greensburg, Kansas, Columbia, Maryland, and Georgetown, Texas, and Kodiak Island, Alaska. They are already 100%. They're already fueled 100% by renewable electricity. So this is possible. This is happening right now. It's going on already. Regardless if you have Democrats or Republicans in power in your state, it is possible. It simply makes huge economic sense to continue with fossil fuels. If we use a photovoltaic system, it can reduce 69 to 100 million tons of carbon dioxide, and that can have huge impact on our climate. It can really protect us from those devastating RCP 8.5 that we saw in Lab 2. And again, this is possible just because it makes economic sense and not only environmental sense. Economy and environment are not mutually exclusive, we can create more jobs, we can build very strong, very resilient economy if we go with stronger reliance on renewable energy. So as you can see here, the cost of photovoltaics that are used for generation of solar energy has dramatically plummeted in the United States and in Germany and everywhere all over the world. So it simply makes sense economically today to go with solar and wind and not with fossil fuels. Now, the next area where we need to look at is what we can do in terms of climate change adaptation strategies. So differently from mitigation, adaptation are adjustments in ecological, social, and economic systems in response to actual or expected climate stimuli. And the significant role of adaptation as a policy response by government has been also recognized internationally. So all major international agreements call nations both for climate change mitigation and climate change adaptation. So there are many different forms of climate change adaptation, and we do need climate change adaptation because even with the best case scenarios, even let's say, like we went with commit scenario as a world that we saw in lab 1, which is probably not very realistic, we would still be experiencing some impacts of climate change for a very long period of time because of all the carbon dioxide emissions that are already in the atmosphere. And so as we develop in different adaptation strategies, they can come in different shapes and forms, and they can be administrative, they can be legal, they can be political, they can be financial, they can be managerial, they can be institutional, organizational, structural, technological, and so on. So these adaptations can come in terms of our tax incentives or in terms of local policies or federal policies, and uh, they help us to survive and thrive under all those different impacts of climate change. So here are some recommended climate planning steps. Of course, in any area, we need to start with good understanding of what are our greenhouse gas emissions. In any area, we need to have good grasp and educate the public about how much, what kind of economy we have, what emissions we are producing, and go from there into development of climate change mitigation plan. So every city, every state, every country, every business should have climate change mitigation plan, and this is actually now legally binding in many parts of the world. Climate change mitigation plans are required in many places now, from the local and state governments. In the United States, we still have very kind of diverse state-to-state approach. So many states now do have climate change mitigation plans, but not all. And it very much depends on kind of the state view on climate change. Okay, we also need to have vulnerability assessment to understand how we are impacted by climate change. And based on this vulnerability assessment, including exposure, sensitivity, and adaptive capacity, that leads us to good understanding of how different groups of population are impacted by climate change. We can then develop climate change adaptation plan. So again, every local and state and national government should have, and every business and probably every family today, it's really beneficial to have your own climate change adaptation plan. My research is actually focusing on climate change adaptation planning by local governments, and I am doing research with my colleagues in France comparing climate change adaptation planning in small cities in the United States and in the European countries. So climate adaptation planning really significantly can help reduce harmful impacts of climate change, and also, probably take advantage of some opportunities related to climate change. And All this makes our communities more resilient. So climate resiliency plan is more integrative climate planning. It should build on climate change adaptation, but also include other aspects, resilience, resilient economy, energy conservation, and of course, climate change mitigation. And climate change adaptation really should be mainstreamed today too at all levels of the society. It should be mainstreamed into master planning for cities. It should be also mainstreamed pretty much in every sector of our economy. So here are some desirable attributes of climate planning that I want you kind of to leave to think about. They need to be clear goal setting, very clear decision-making processes driven by specific, achievable, result-oriented, and time-bound objectives. They need to be context specific. They need to be based on vulnerabilities and risks specific for the area. They also need to be informed by the best available science. Just like as we are planning for COVID-19, again, we need to listen to scientists. The same way that we need to listen to scientists when we are dealing with vulnerability to climate change. Reliance on political will, support of diverse stakeholders, including civil society, is also very important. We need good coordination of climate change mitigation, adaptation, disaster management, sustainability, and resiliency planning. We need good coordination. We also need good degree of flexibility and ability to cope with uncertainties and complexities of climate change and non-climatic factors. And we clearly need integration across multiple sectors and scale. If we just have good climate plan, let's say at the scale of Grand Rapids, this is a good start, but it would be much more powerful if that local climate plan is also integrated with a state level plan and with national policy. When everybody on the same page and everybody is working together, it's much easier to achieve good results. As again, we are experiencing, sorry for making so many analogies between COVID-19 and climate change, but I think right now we have pretty much almost full year now of, at least 10 months of illustration of what we shouldn't do as a country. And so I really hope that as a society we learn something from those negative experiences of inefficient management of this pandemic. I hope as a society we would also learn something about managing risks of climate change. So bringing everybody, unity, bringing everybody on the same page, developing bipartisan approach and involving all the stakeholders and integrating all levels of the government, integrating institutions is extremely important to achieve positive results and achieving effective results in disaster management or in pandemic management or in management of the impacts of climate change. And we also need continuous monitoring and assessment because we need to learn from our mistakes. We need to monitor, we need to see where we are, if we are doing right things or not, and we need to be flexible enough and kind of learn from those experiences, reassess, and develop new goals. So I want kind of to leave you with all those thoughts as you are working on your own projects and develop ideas on impacts, vulnerability, and adaptations to different impacts of climate change in your own case studies. I want to remind that the readings for this unit include the IPCC Assessment Report 5 by Working Group 2. Of course, it's available online. We have been working with it now for a few weeks, helping us to focus and decide on our case study areas. Again, you don't need to read the entire report. Just browse, skim through the areas that are relevant for your projects. And of course, attention should be on your project topic and your project region. Our second major source of readings is the National Climate Assessment published in 2018. This is volume 2. And in this unit, we are reading chapters 2, 3, 5, 21, 28, and 29, and all the links are available on the Blackboard, and they're also listed weekly in my reminders sent on Mondays, and also in the syllabus. Finally, we have several additional optional readings on vulnerability and adaptation also available on the Blackboard in the readings folder, and I am asking you to read or at least skim through Azure, the paper on vulnerability, Polsky, being building comparable global change assessment. So this is vulnerability scoping diagram that I was showing in this lecture. And then I also encourage you to read Lisnikovsky and all how we are adapting to climate change. This is a more recent paper, and my recent paper on local climate change adaptation planning. And this concludes Unit 2. Please email me as always if you have any questions, and of course live tutorial for this class is available every Thursday at 10 o'clock from 10 a.m. To 12 p.m. And I wish you a very nice week.